Hello? Hello, sir. Hello? Hello? Hello, sir. Sir, am I audible? Hello?
Hello, Aman. Can you hear me?
Yes, sir, I can hear you. Yeah.
Yeah, sorry. I was just setting things up a little bit more comfortably for me. So, yeah.
Okay, sir. Good evening,
Hi,
sir.
my name is Prashanth. Nice to meet you. Can you just turn on your camera for a bit, dude? Hello, can you hear me, dude? What is this? Okay,
Hello?
so all right. So you also work on a similar basis as me. You listen from one device and you need to switch on another device for video. Okay.
Yeah. No, sir, I'm on one device. It's just that my internet is not that stable.
Okay, all right. So Himatej did not explain too much. What he did explain was that what to say, just a little bit about who you are. So can you just quickly tell me who you are and what your situation is like, so that I will have a better idea as to how I can help you.
Yes, sir. Sir, my name is Aman Krishna. I am currently in 11th standard. I'm studying in Fiji, Miyapur. I previously studied in Amateur World School and I took Cambridge syllabus. And I've been taking classes with Himatej sir and his teachers for the past 1 year, nearly.
Okay. Okay. Tell me about your background more. what is your academic situation like, and what is your scenario with respect to how you're doing in wherever you are? You can switch off the video, dude. I think that is going to be a drag for you. You can switch it off. Hello, Aman, can you hear me? I think your signal is not coming through because your video is on. So switch it off. It's okay.
Okay, so I'll try to connect to my hotspot.
Cool, huh?
Give me one second. I think that might be better.
When you connect, you switch on your video. Till then, let's just converse. So, tell me what your situation is like. You are in 11th standard, is what you just said. So, Himatish told me that you are in the FITG integrated program. Is that correct?
Yes, sir. Yes, sir. Yes. Yeah.
And can you tell me which phase you guys are in right now?
Phase 2, sir.
Phase 2.
So far we've completed, yeah.
Okay, so
we've completed stoichiometry, atomic structure, and periodic classification elements, and we're on chemical bonding right now.
Okay, all right. So you've just covered phase 1 alone, and how much was your how many marks was the mid phase exam for?
The phase exam, sir, we had one main paper and one advanced paper, and in I don't advanced paper was out of 60. I don't remember exactly how much I got, but I think in chemistry, I don't exactly remember. I think somewhere around the 45 to 50, like 45 to 50.
So what is your general comfort level with respect to chemistry as a subject?
Chemistry is interesting. I like chemistry, and but a few times it kind of gets confusing. But like so far, what we've done so far, I have understood, and it's interesting to me as a subject.
What do you mean by it is interesting to you, and what do you mean by it has been a little frustrating once in a while? Can you explain both parts?
Yes, sir. So I mean, when it makes sense, it's interesting and it's logical and all. But then when the exceptions come in, it doesn't really make sense to me.
So, can you explain what you mean by an exception, and what exactly did not make sense to you? Take an example and make it more clearer. Is my voice clearly audible?
Sir, it's clear, sir. Yes.
Yeah,
So,
sorry, I like to pace around when I'm teaching. So, yeah.
Yes, sir. Yes, sir. Yeah. So, I guess one example would be that Li plus is larger in size than Mg2 plus, and Mg2 plus is larger in size than Al3 plus.
How is that a problem for you?
I mean, I'm just curious as to why that is how it is.
So, if I'm asking a question, say, why are you, how tall you are? Can I give you an answer for that question?
Yes.
What answer would that be?
Sir, your voice broke. Can you repeat?
So, if I'm asking you a question like, say, why are you, how tall you are? What kind of an answer do you expect for that question? What kind of an answer would you be giving for that question?
I mean, there's no exactly.
You can give some answers, right? What kind of an answer would you give?
Yeah.
If I did ask you a question of that sort.
My parents
You'll
are
say
not
your
that
parents
well,
are. Basically, you'll give genetic answers, correct?
Genetic.
What are genetic answers? Genetic answers are basically fact-based answers, correct?
Fact-based, yes. Random, kind of.
So, empirical answers, put it that way, because they are based on data directly. So, first of all, you need to understand one fact about any subject. What are you trying to do here? You're trying to learn, correct? What does learning mean? Can you explain how you learn things? How do you learn normally?
To
How
me,
did you learn physics? Himatej told me you're good at physics. So how did you learn physics? I'm a physics person
I'm,
actually. I'm an electrical engineer who
oh,
teaches chemistry. So yeah,
I see.
I'll be approaching shit from a physics angle quite often. So what exactly, how did you learn physics? Tell me.
Well, generally, generally in any topic, I first listen to the concept clearly and then try to make
What
sense
do you
of it.
mean by
And then
listening to the concept? Explain that part
listening to the
first.
concept, um, like the fundamentals of the topic, pretty much. Like,
See, again, you are being vague. Be specific. I want specific answers. What do you mean by fundamentals of a topic? What do you mean by concepts there? Before you go into anything, let's take physics, some topic as an example. Take any topic. Pick a topic.
laws of motion.
Okay? Laws of motion. So, in laws of motion, for understanding laws of motion, you need to have some basics required there, right? What are the
Yes,
fundamental
sir.
things which you need to know laws of motion properly to understand laws of motion?
Basic knowledge of kinematics.
What does that mean? What does that entail?
Mm, I mean, you need to know like the basic definitions, of
Terminologies, what are we
terminologies.
observing?
Yes,
And
yes,
most importantly, what happens when something is hitting something else? And what happens when we throw something else up or down, or how objects
yes,
interact with each other, correct?
yes, yes, sir.
So now
Yes,
these are data, facts, which you need to know before you even start dealing with laws of motion, correct?
yes, sir.
So if you were somebody who did not even know about this, if you have never thrown a ball around, if you have basically never played with objects in your life, would you be able to understand laws of motion?
Not very, no, not very easy.
So why is it that you understand physics better? Tell me now.
Because we have previous knowledge of the
Because you have been
what
collecting
happens.
data throughout your life.
Yes, sir.
All right, that's the
Yeah.
reason why you understand physics better. So if you look at what the subjects which you learn are, physics is basically going to be a study of the macro systems. Anything which is our realm of size or larger than us, we generally end up discussing in physics. Anything which is too small for us, where we can't really see that stuff, then we basically end up going into a chemistry domain. And there is a caveat as well beyond that. For instance, in chemistry domain as well, if you look at it, when it goes too small, mathematics has to be applied, because ultimately, when you look at chemistry as a whole or physics, basically, they are both, what to say, ways in which we understand reality. And mathematics is effectively nothing but the language in which reality is written. So the
Yes.
universe is basically written in mathematics. So we have to basically connect these three pieces together. That's the end game at any stage, basically. Now, when we're coming back to what your original question was, what is an exception first?
A fact.
It is a piece of data which you have not connected yet. That's the thing. So
Yes, sir.
effectively speaking, you need to understand that in physics, you have been collecting data for ages. Since you have been born, everything you have been dealing with in life is basically collecting data for physics. And you understand it obviously because it's obvious. It's
Yes, sir.
natural.
Yeah.
So
Yes.
moment you start seeing a case where this pulley is done, oh, you have seen pulleys. You know how the thing works. You have not never understood how it really worked, but you have seen and you have played with that stupid thing at some point of time in your life. So
Yes, sir.
effectively speaking, you are able to connect the pieces more easily when the mathematics is introduced. So learning effectively is like this. There are multiple stages of learning. First stage of learning is collecting data. You have to collect data properly, not outside, inside your brain. That's where the key difference comes in. Data collecting, you can collect data in your bloody laptop or your phone or whatever. That is not collecting data. Collecting data has to be done inside your brain. That's the first stage. After you've collected the data in your brain, you basically end up learning the concepts behind how the data connects internally. That is where conceptual stuff comes in. So if you do not do the data collection in the first place, you directly jump to conceptual, you won't make sense of it. Because it's like you're basically trying to weave strings between points or variables where you don't have the variables. So a string doesn't stay. It's not holding intact. You understand the
Yes.
analogy I'm trying to make
Yes.
over here, right? So
Yes, sir.
the idea here is you have to first throw your resistance towards collecting data. If you want to do well in chemistry, if you want to really understand chemistry to the next stage, to connect the pieces between chemistry, physics, and maths, you have to first throw your misconception with respect to data. So data collecting is the first and necessary step in chemistry, because you don't have data. You have data for physics. You have data for mathematics. You do not have data for chemistry. You have like random, unconnected, unnecessary pieces of data. You need like structured data first. So collect structured data in your brain first. Then you start understanding how those pieces of data connect conceptually. The third stage is going to be basically sleeping on it. So when you sleep on it, what happens is your brain basically starts making the connections between the data it has acquired and the conceptual pieces of information which you think of as concepts. But remember, conceptual shit is also going to be data only to your brain, because in your brain, everything is data. Till it makes the connections between those neurons, this is data. It is not understanding. So you have to first feed it relevant data points, which are like flags, which are going to be there, flag posts, so to say. Then you have to connect the pathways, so to say, with your understanding and your concept. If you do that, then you can basically forget the unnecessary data. That's the last stage of learning, unlearning, effectively. So you have to understand and approach chemistry slightly differently compared to the way you approach physics and mathematics. That's the first key thing. You have to throw your resistance towards memorizing here in chemistry. If you do not memorize, you will not understand. The first stage is memorizing, then it is conceptual learning, then it is understanding in the brain, then it is unlearning the junk. Forget the unnecessary crap. So that will automatically happen once you've made the connection. So that's the basics behind chemistry. So now tell me, if you're going to be having, say, lithium plus and magnesium 2 plus and aluminum 3 plus, does that make a difference? How does it matter in the large grand scheme of things? Is that something which is a meaningful point to really waste your brain about? Who gives a crap if this guy is fat and that guy is slightly thinner and that guy is slightly thinner? How does that make a difference in life?
Yes.
You understand where I'm coming from, right? So the
Yes, sir.
idea here is that person is thinner because of their circumstances, their genetics. Who cares what the reason is internally? There will be a reason. What is going to be the reason? The reason is effectively going to be that some force is more dominating than some other force. That's the basic idea. In chemistry, wherever you can't understand why something is happening in an unexpected way, look at the forces which are at play there. For instance, in this case with lithium plus and magnesium 2 plus and aluminum 3 plus. Honestly speaking, in this particular case, what was the comparison you made here? Give me the exact comparison you talked about here.
Atomic radius.
Are you talking about the ionic radius or the atomic radius?
Sorry, ionic radius, my bad.
So which ions are you talking about, and what was the comparison you made here?
Li plus has a greater ionic radius than Mg2 plus, which has a greater ionic radius than Al3 plus.
Okay, so think of it like this. If I'm going to be having, say, imagine an example where you're going to be having, what is the real problem here? The real problem here is you think the sizes are unexpected. Why do you think the sizes are unexpected? Tell me that first. You think this is wrong, no? There should be a reason for you to think this is wrong. Why do you think this is wrong?
I mean, they don't align with my logic. Like my.
What is your logic here? No, that's what I'm asking you. What is your logic here?
I would say because Al has more. It has more shells, pretty much. So I think it would, like, it's obvious for anyone to think that it would be larger, but I'm wondering why it's the smallest.
So, what is your imagination of size of a species? First, let's go with that. What do you think size is?
I didn't understand the question, second.
We are looking at ionic sizes, correct now?
Yes.
How would you define size? What is your imagination with respect to size? If I say size of an ion, or what kind of a visual do you have in your brain? How do you imagine that situation? Remember, chemistry is all about fucking imagination, kid. I told you just now, it's all about what is a data and then conceptually getting the data connected, right? When you have the conceptual part there, what does conceptual mean? Conceptual is just going to be a bunch of facts. till you put an image into your brain. ऐसा है, and this is basically what's happening. Once that image is made in your brain, this is the way the system is actually. If you've got a good visualization and a good imagination, then the brain can make that third piece of the puzzle more easier. That is, first is basically collecting data in your brain. Second is conceptually getting the information, which is also collecting data of a different type. Third is basically sleeping on it, letting your brain understand it, fermenting the information in your brain, so to say. So that fermentation is something which will happen more easily if you've got a more holistic imagination of what's happening. So tell me, in this case here, how do you imagine the size of an ion? What would be a way to imagine it, which will help you get most of the information which you need to get correct? Remember, pay attention to the words I'm using here. I am very careful with at least the words I use when it comes to chemistry. I am fairly loose with respect to everything else, my wording, but when it comes to subject wording, I'll be very careful with the words I use. So in this case here, the words I used were along the lines of what visualization will be most effective here for you to not remember most of the data. You are hearing me clearly, I hope.
Yes, sir.
See, you got data in the first place, right? Yes, what's the data? You know, lithium plus is larger in size compared to magnesium 2 plus compared to aluminum 3 plus. That's the data.
Yes.
You have been given some concept which you're not accepting.
Yes.
Correct?
Yes, sir.
Now, you need to basically come up with some visual understanding of this system here, which will help you accept the data in a more meaningful manner. If you have that kind of a visual understanding of this data here, what happens then? You will remember it automatically in your brain with that visual representation. So let me give you a visual aid here which will help you. So think of it like, let me ask you let me point you in a different direction here. What happens when a system loses one electron? How does a system lose an electron? Does any system want to lose an electron?
Well, it depends on the initial stability of the stability, meaning depends on how many electrons it needs or doesn't need to.
Let me rephrase the question. Stable. Shut up and one second. Let me rephrase my question here. If I am going to be having any ionization energy value, is it negative?
Okay.
Is there any ionization energy value negative for any system?
No, sir.
So what does that tell you?
That means you need to provide energy to remove an electron.
Yes, but what does that tell you?
That means it doesn't want to lose an electron.
Yes. What does that mean at the end over here? That means the system is happier with the electron in the first place, correct?
Yes.
Okay. So now the system is happier with the electron in the first place and it does not want to lose it. So let's say it lost one electron. It desperately did not want to lose it. That's why it basically was holding on to it tightly. It lost it. So it's basically like somebody who is basically walking on the road and has had their chain snatched from them. Correct?
Yes, sir.
Something which they valued has been taken away from them. They fought for it. They couldn't get it back. It got taken away. Effectively, right?
Yes.
So let's say you have been robbed once on the road. How will you walk the next time on the road? Will you walk in the same carefree manner? Or will you end up making yourself a smaller target? Something which is going to be more difficult to approach, something where it is going to be far more difficult for you to basically lose that system. Obviously, it's going to be that way, right? That's effectively what's happening here as well. When you look at each of these systems here, what starts playing a bigger role is the fact that you're going to be having electrons being lost. When electrons are being lost, each time an electron is getting lost, what is happening is you're going to be having the number of protons remaining the same in the bloody center of the nucleus. Okay, so look at the forces which are playing inside the system size over here. When you want to look at the size, what does the size basically talk about over here? The size is basically the net space occupied. We can imagine it in that fashion here, correct? Net space occupied. Of course, that is not a correct way of looking at it, because when you look at it from the point of view of where the electron technically can be, it can be anywhere. But If I'm roughly bounding it within a reasonable space, net space occupied. So if I'm looking at the size of a particular ion, what are the systems which are at play here? What are the forces at play?
The attractions between the nucleus and the electrons.
Mm-hmm.
Uh,
What else?
the repulsions between the electrons, the inner electrons and the outer electron.
Repeat again.
The repulsions between the inner electrons and the outer electron.
Okay. So effectively, we are having inter-electron repulsions and nucleus electron attraction being the main forces at play. Correct?
Yeah.
Yes. Okay. Now let's look at one point over here now. If I'm going to be comparing, say, any system which is going to be having one electron lesser compared to its neutral state, what happens there? What is increased? What is remained the same? What has decreased? Has anything happened overall?
So the net attraction towards the net force will be acting inwards, little more than the neutral atom.
Let's not look at net force. I'm looking at what are the forces at play now compared to the neutral system. That's all. So if I'm looking at, say, the system now, it is smaller in size, correct? It's an ion now, it is basically smaller in size. So if it's smaller in size, the nuclear electron attraction, is it now higher?
It's higher.
Much higher, correct? Because of the smaller size. How about the electron-electron repulsions? What happened there?
Well, the lesser electrons, so there will be lesser repulsions.
Correct. And more importantly, in this case here, you can also argue it is in lesser space technically. So maybe there might be more repulsions, and also you can argue that way but the problem here is that doesn't matter over here because the space which an electron occupies is extremely tiny compared to the space of the atom over there, or the ion in this case here. So that part of it negates the system over here to an extent. So you'll end up having net electron-electron repulsions decreasing in the system here, correct? Now, scale that up when you're going to be having one more electron being removed. What happens now? Your number of protons are still remaining the same. That is not changing. Size has decreased even more.
Yes.
And it becomes even more smaller than expected always. The size of decrease will not be one level only. It will be an exponential decrease. Why? Because the fact that when the size decreases, you're going to be having more attraction automatically. Because the protons are remaining the same. They are attracting electrons which are now closer to the system. Right?
Yes.
So the magnet or the charge which is attracting at the center is far more, potently felt. Because the fellows which are getting attracted are closer automatically now, and the fellow which was doing the attraction has not lost its strength.
Yeah, got it.
All right. And at the same time, what was originally a little bit of a fight between them is now becoming more
significant.
ordered.
Yeah.
No, it is not becoming significant. It is becoming less significant.
Yes, that's right.
So effectively speaking, the decrease in size becomes much more steeper. Not exactly a proper exponential decrease, but a much more steeper decrease when you are having the charge increasing positive charge wise. So when you're looking to compare charges or when you're looking to compare ionic sizes, a more meaningful way to compare is based on the positive charge of the system first. Then you go for the other factors which you normally go with. Go with the positive charge first, then you check for the other factors. Aluminium and magnesium are going to be a little bit more, complicated to compare over here with lithium, mainly because of the fact that they are not in the diagonal relationship also in any way. Lithium and magnesium to bol sakta hai, diagonal relationship mein hai. But magnesium and aluminum are going to be in the same period over there. So it's a slightly awkward comparison because of that. When you're doing awkward comparisons, it is always better to have, how to put it like this. What is an awkward comparison? Let me define an awkward comparison in the first place. You'll understand that better, slightly maybe. I'm going to be having a large bunch of data in my brain, let us say, which is like ordered properly. If it's ordered, I can forget. What is an order of data in my brain? That is basically a pattern which I understand automatically. Where I have got a proper visualization, I don't need to remember that anymore. I can basically forget the data associated. I can make the links automatically. Now comes awkward data. Awkward data is data which is not in the same branches of order, which are in different parts of the ordering over there. So you have to compare different streams over there. Sometimes it is easier to compare those kinds of data when you are having extra data which is going to act like markers, which will internally
Yes.
help you point out key, this guy is going to be above this guy is below this. You don't need
Yes.
to remember individual things. You remember like marker points in terms of the data there, which
Yeah.
will help you. This is one of those kind of marker points which you can remember. This lithium, magnesium, aluminum. So usually what happens, from what I remember, this used to be one of those textbook questions or package questions a long time back. I don't remember whether those things are still valid. You're in CRP or you're in integrated, na? But book should have
Yes, sir.
changed. Anyway,
United.
chalo. So Miyapur, who is the boss in Fiji now? Is it Anandaraman sir still?
No, sir. No.
No,
In our branch, HOD, I mean, our head is Nagaravi, sir. Mathematics.
I do not know. I think Anandaraman sir is the overall director for Hyderabad. I think I do not
I think he
know.
teaches in
Chalo.
Malapur, sir. Yeah.
Maybe I do not know him particularly.
Okay.
Right
Okay.
now, I do not know what's the situation. Anyway, I used to be in Fiji 8-10 years back, so yeah, it's been a long
Oh,
time.
okay.
Not here though, in Chennai. So,
In
been a
Chennai.
while.
Okay. Yeah.
Anyway, so let's come back to the question here. See, you have to first shed your resistance with respect to data in chemistry. This point which you raised here, this is an exception. All of that is fine. Accept exceptions are as data which you have not connected yet. Once you connect, you throw them away. It doesn't matter. So it's all about what to say, reducing the resistance to the flow of information into your brain. If you end up building blocks, ki mujhe, what to say, all of this unfortunate pop culture and general culture is like, what to say, I will only learn, मैं सीख के करूँगा, वो सब nonsense है. वो सब, that is all detrimental to, what to say, that is meant to keep people sheep, effectively speaking.
Yes.
So it's not really meant for much else. So if you're looking to, what to say, take things seriously, you will have to basically accept that memorizing is a tool and treat it like a tool, which it is. It is a tool which has obviously problems. You only depend on it, it will screw you. If you end up using it the way it has to be used, it will be very beneficial in terms of understanding itself. So tell me, what kind of problems do you find in chemistry in the topics which you have gone through till now? And how do we go about this thing? Because honestly speaking, I have not taught individual kids ever. I have been dealing with only like larger classes, and
Okay.
what to say, I've been in an edtech for a while now. So startup type of situation, so to say. So
I see. Okay.
effectively speaking, I will go with your flow. So you tell me what issues you have. We will start fixing them. Ideally speaking, what I would look at over here is, if this is going to continue on a slightly long-term basis, I would like to, what to say, if I'm looking at what are your ambitions first? You tell me that. What do you want out of this? What do you want out of this? I mean, you're a kid who is attending Fiji and attending evening classes. So this is hectic. So
Yes, sir.
let's
Yeah.
try to basically get to what you want out of this. What do your parents want out of this? I'm assuming your parents are not with you now, yes?
No.
If they are, that's cool as well. So make your wants
Yeah.
clear. Make what your parents' wants are as well clear. Then we will see what I can help you with and how to proceed with that.
Okay. Yes, sir. Uh, what like well, my long short-term goal would be to like do good like in whatever exams come up and uh just do good in them. But in the long term, I would hope to do something in the mathematics field, possibly research, because I find mathematics very interesting. It's my favorite subject. So
What type of
something
mathematics
along
do you
those
find
lines.
interesting? What type of mathematics do you find interesting?
Sir, actually, I haven't like researched much about it yet, but number theory maybe um seems interesting to me.
Mhm. Okay, all right. Okay. And why do you find it interesting?
Uh, it's like,
It's kind of novel, and it is out of your regular syllabus, and
yeah.
it is easier to basically outshine other kids in compared to other parts of mathematics. At least that's why I like number theory.
Oh,
And so yes, give me a second. I need to hook up my PC.
yes,
Um,
sir.
charging. Yeah. So at least that's why I used to like number theory when I was younger. And as long as you've got enough ability to find information on the web, you can always outshine your competition at that level much more easily in that topic.
Yes, sir.
Is that your reason? I hope it is not.
Oh, no, sir, no, no. Like it fascinates me like to see whatever you can do with math, like especially number theory. Like I would have never thought that you could solve like such problems. But then the fact that you can solve them, like it
Honestly
blows my
speaking,
mind.
more than number theory, if you
Like
really look at the genius of mathematics, na, calculus is the bloody crux of all genius. Number
that's
theory
true, yeah.
started off first, then you ended up having what to say, geometry, then algebra, then the mother, which basically ended up taking over everything else and propelled physics and chemistry to the next domain, which was of course calculus.
Yeah.
Anyway, that's besides the point here. So you haven't given me a more clear answer yet. You have just given me a vague answer that you want to follow mathematics. Tell me, at what level do you wish to follow mathematics?
Well,
What kind of an
I would
institute are you looking at?
hopefully an IIT, and then after that, I would hope to. I'm not sure if I'm like going to ahead, but like maybe like pursue like maybe a PhD in some topic in mathematics.
Where exactly? Which kind of institute?
Uh, Maybe abroad, somewhere abroad. Uh, I haven't really thought about it much, but to be honest, anywhere would be
So,
fun as long as
so effectively, you're looking to get a top level degree from any good institute, which will basically help you
okay.
push your prospects with mathematics further.
Yes, sir. Yeah.
Okay, so that is your prospect with respect to long term for this. Now tell me, medium to long term. Short term, you already made it clear. How about medium to long term?
What kind of time range is this? Like next few months? Is that what you mean? Or?
No, not next few months. Next few months, you already made it as short term. Let me be
Okay,
way more
that's
specific over here with respect to JEE itself. What kind of a rank are you looking for in IIT? What kind of a course are you looking for in IIT? And what kind of IIT are you interested in? And what are you willing to settle for? That is, what do you want and what are you willing to settle for?
what I want is hopefully I genuinely don't know much about the topic, but mathematics and computing maybe.
Mm-hmm.
Like I had an interest in computers like before I like maths, but then and
Mm-hmm.
maths, so like combining both kind of seems cool. So that's one reason I would like to do that. And coming to where on, I don't mind where it is, but as long as like I have good education there, and I'll
Those are vague
try to do
answers,
whatever
dude.
I
I
can
am
do.
looking for specific answers where, see, let me be blunt about why I'm asking these questions. I want to know how much you want me to push you, basically, to be very blunt.
Okay, I get it. Yes, sir.
Because the simple truth is, if you have wants which are going to be high, and if you're going to be having settling things also being high, that means you set the bar up to a reasonable extent. So that gives me an idea as to what is the necessary level you need to go up towards. So once I find out what is your actual position, I will know how to basically how much push is going to be required. That's why I'm asking you what is it that you're looking for at the end goal of this course, of your 2 year course in Fiji.
Well,
Any IIT would do, or a decent IIT with a decent course would do, or are you specifically looking for math and computing only, or what to say? What are the possibilities?
my options are still open. Like But as of now, I would like to do something in the mathematics. I'm not sure if IITs have a purely math course. I'm not sure if they do, but I would be interested in that as well. But uh, as of now,
If
I'm
you're
fine with
looking for a
anything. Like,
mathematics course, the actual pure mathematics course is the one which I did, electrical engineering. So that will have a lot of mathematics in it, not much physics, tremendously large amount of
okay,
mathematics. So yeah, math and computing will have a little bit more of computing and a lot more of algorithms. Um,
yes,
it will have
okay,
deep number theory though. It will also
mm,
have a large amount of algebra, deep algebra, and
yes, sir.
it's a different type of domain. Anyway, that's besides the point. So, what type of scenario would your parents be looking for you for? Because ultimately,
They
to be very honest with you, you are the client, but the customer is your parent, both for Fiji and for us. So
yes,
I will have to make sure my customer and my client is satisfied. So
yes.
tell me what the customer is looking for.
Well, they don't really mind. They are okay with me getting into anything good, but they just want me to like work hard and try my best. But I want to set my own bar. Like,
So you
I don't
want to
know.
basically, obviously, I mean, you're at the age where you have to push your goddamn boundaries. You do not do that, you're not doing something right. So yeah, fair enough. All right. So tell me, how was your chemistry with respect to the overall balance of the three subjects?
If I were to talk about like which one's my strongest, well, so far chemistry has been okay so far. Like I haven't had too much trouble with it, but compared to other subjects, I would definitely say physics is my weakest subject. Then probably maths, and then probably physics. Sorry, chemistry, man.
So physics is your weakest one, then chemistry, then mathematics. Maths is your strongest suit.
Yes.
Okay. So chemistry lab, what kind of grounding do you have in chemistry? Till 10th, where did you study? You study in an international background, is it? IB?
Yes, sir. Yeah. No. IGCSE, Cambridge.
IGCSE. Okay. And where was this? Which place? Hyderabad?
Uh, yes, Hyderabad only, sir. Yes.
Okay. And for how many years were you in that background?
From 7th to 10th. 7th to 10th. Yeah.
7th to 10th. And before that?
Yes. Before that, I lived in the US, sir.
So you have an American citizenship.
Yes, sir. Yeah.
So are you looking at foreign universities for what to say undergraduation?
No, sir. But further education, then probably yes.
You
Like
can.
MBA.
Okay. No, I understand. Yeah. So
Yes, sir.
okay.
Yeah.
Okay. All right. So hmm, what is your day like? How many hours do you give towards studying? Because I'll be very honest with you. I think you probably already realized it. That's probably why you are in this place over here as well, other than Fiji. Um, if you're in an integrated system, the kids who are in that system are already slightly ahead, purely with
Yes,
respect
sir.
to the data collection. They have collected a lot more data over the years. That is
Yes, sir. Yeah.
the reality. So bridging that gap is going to need a little bit of resilience and how to say a little bit of a buffalo skin because ultimately one needs to develop a little bit of a thick skin. What is your position in your campus? Which batch are you in, and what's your rank in your class?
Sir, I'm in the top batch in Miyapur,
Mm-hmm.
J17, and well, coming to my rank, it kind of varies because other people are around my skill level, and it fluctuates pretty much through exams. But in my class, there are 35, 36 people, and I would say I'm in the top seven.
Do you guys get
Fluctuates.
city-wise ranking, or you guys only get
No, no,
campus
no.
ranking?
Well, we have common exams with the Kukatpally and Madhapur campus, and
As
yeah,
of now, AITS would not have started, nah? This will be like
No,
half
sir.
as
No.
middle type of AITS. Not even AITS. It will be like some common face connection, some face
Yes, sir.
exam
Yeah.
type thing, na?
Yeah. Just normal weekend tests and all.
Okay. So, all right. I see that my computer is not connecting properly. Let it connect. The phone is still doing well. So, yeah. Is it your system which is disconnected or mine, dude? I think
Now
mine
you're
only, na?
visible, sir. Yeah, I
Now
think
I'm
it's
visible,
yours.
so mine only then. Cool.
Yeah.
Anyway, so okay, let's start off then. Ideally speaking, chemistry-wise, what I would prefer to be at in this kind of situation, if it's a long-term thing, based on your goals here, I would prefer to go with something like this, where what I say, in an ideal scenario, we are like say discussing a topic, let's say this week. That topic is going to be discussed in your classes next week in your school or wherever you're basically attending Fiji classes in Miyapur.
Yes.
And what to say, one round first here to some extent, not exactly full clear picture type of thing, a basic idea and a general structure as to what are the points which you need to pay attention to and what are the concepts which you need to understand and what kind of a general overall visualization which you should you capture in that particular topic. And what to say, that would be the ideal way in which I would prefer to go. The second thing would be basically your class, jo bhi tu padega. You understand which languages, dude?
Sir, Telugu, Hindi, English. Hindi, I can understand,
Broken,
but I'm not
manage.
too fluent in
Yeah,
speaking.
cool,
Yeah, I
cool,
can
cool.
learn. Yeah.
Cool. Okay, so I'll try to stick with English as much as I can. So effectively, the idea here, dude, is in this case here, first round will be like what to say with one round of me and your own general revision of the topic, so to say. When I say revision, let's call it what it is. It's not revision. It's like going through the topic vaguely. Then you basically end up learning things from your class point of view once properly. Then you basically come back and fix the issues because there will
Okay.
be issues. And once that is done, you can basically sit and practice. And
Got it.
practice is going to be absolutely mandatory. There is no escape. Now, why is practice mandatory and why is there no escape? Because um, since you've come from a different country or you've lived in a different place for a while, you'll understand this example. So let me give you an example in that point of view. If I'm looking at, say, the way I speak in here or the way you speak here, you have a particular accent, you have a way of pronouncing some of the words, you have a way of enunciating certain parts more clearly. That is going to be changing when you're in a different country, right? And a person there may not understand the way you speak over here and vice versa. Why is that happening? Why is there a communication gap? Because ultimately speaking, what do you say, there is a disconnect. That's why there is a communication gap. So that communication gap will exist between what you have learned in school, wherever, and the actual examination. The way to bridge it is by actually going and seeing old JE questions. There is no escape beyond that. So you have to basically look at this as what to say. Do not like this metaphor, but this is like basically preparing for war to an extent. The war is a long time away, so to say, and it's a very short war. But what to say, you have to effectively prepare for it as efficiently as possible. And
Yes.
the previous JE questions are effectively, well, previous data. So unless and then you have the previous data and you understand the general language which is followed in that, you can't really expect yourself to master the examination automatically. So other than what we talked about in terms of learning, there is a last stage as well over here, which is going to be connecting your learning to JE. That last stage requires you to practice sensible questions on a reasonably large scale. When I say reasonably large scale, it is not undoable. You're in 11th standard, you got 2 years, dude, so it's not a problem at all. You have sufficient time to basically crack it. So that's effectively the situation. So that is in an ideal situation, but I don't think we'll be in ideal for a long time. So temporarily, short term, you want to basically see how short term we can basically proceed here. So tell me, what are the topics exactly which are being dealt with in your general lessons now? Let's discuss a couple of those topics. Let's clear off any doubts you have, and huh, we will see I want to see what your level is at in terms of understanding. So let me share a screen directly. Can you see my screen sharing too? Let me see how this looks.
I don't see anything. That's it. Yeah, now
I
it's
also
loading.
don't see anything yet.
It's loading now.
Internet is shaky here. I'll have to figure out another spot.
Yeah, it's visible, sir.
You can see now?
Yes, sir.
You can see my face again, Nadu.
No, no, sir. I see a whiteboard, a blackboard.
You can see that?
Yes, sir.
Okay. Mm, What can you see now? Can you see the whiteboard?
It's yes, sir. Yeah, I can see it.
Seriously, you can see a whiteboard now? I'm also on my phone over here. I can't see anything here.
I see the menu on the left-hand side, sir. There's like a.
Chalo, let me start writing a little bit and see whether you can see anything here. Can you see me writing anything?
Uh,
Anything visible?
no, sir. Nothing.
Yeah, okay. Give me a second. I'm just going to be sharing my full screen with you, dude. Let's see how that works.
Okay.
Yeah, I think now you can see, I think, right? Now I
Yeah.
can also see.
Yes, sir. Yeah.
Okay, all right. So let's switch this off. Okay, so let's start off with the topic which you are currently at. What exactly is your current topic which is happening in chemical bonding? Is it chemical bonding as a topic happening now?
Chemical bonding. Yes, sir. Yeah.
So
So,
what's happening in that chapter now?
we started Fajan's rule, sir.
Okay, so you're doing Fajan's rules now.
Yes, sir.
What do you understand by it? Do you have any thoughts on Fajan's rules as of now? What are Fajan's rules about?
Well,
What are they telling you?
there are a set of rules which help you to uh, determine the covalent nature of an ionic compound.
So what does that mean?
That means, so in an ionic compound, so in
First,
an
tell me
ionic
what
compound,
does ionic mean?
Ionic means it's a bond between two oppositely charged ions.
Okay, so effectively speaking, it is going to be something where there is going to be direct electrostatic force of attraction, KQ1 Q2 by R squared is going to be at play, correct?
Yes, sir. Yeah.
So have you already learned about ionic compounds in detail for now?
No, sir. No.
So you've just started. What are the topics you have discussed in chemical bonding so far in your class lessons?
So lattice energy, hydration energy, and the structure of a few salts and all. Lattice structures.
Okay. So tell me, what do you think you should be learning in this chapter? What is this chapter about? Chemical bonding, right? What is this chapter about first? What do you think this chapter should be about? If you're ideally learning it in the perfect manner, let's assume that way. What should this chapter be about?
Well, I think it should be about what, um, why there's a bond forming between two species.
Go on. What else?
Um, how does it form? Like what different types? Like how does a bond form? Pretty much, and the different types of bonds which form. Like
And shall I add why?
yes, sir. Yeah.
See the questions which you have asked me here. What are these questions really? Which stage of learning are they in?
Initial stage, like when you're
Is this
collecting the
initial
data.
stage? Is
I
this
mean,
initial stage? The questions you have asked me, are the initial stage questions? Should you be answering them at the initial stage?
no.
You get your problem with respect to how you should approach things. You will get your answers for these now. Because general school principles and the principle of approaching, an examination in India now has become something where we approach it from a competitive perspective. So I would call it as spoon feeding. All right. So we give all the information to the children. You will find all of this information given to you in school or in classes. I will also be giving the same information to you. But are these the questions you should be paying attention to in the first place? At this stage, you are now at a handicap with respect to the other children, correct? You want
Yes,
to
sir.
race ahead of them at the end of the day. The way to race ahead of them at the end of the day is going to be to follow a proper structure where when you learn inside. It doesn't get out again. If you only end up focusing from a completely short-term perspective, that happens. So these are questions you should answer. But before these questions, there's another question to answer, or a couple of questions to answer. What will they look like? What do you think will be the previous questions you have to answer before you get to these?
What is a chemical bond?
How to define what it is? How to define terminologies in this scenario here? And what is the data to collect? Because at this stage, you do not even know what is the data you're collecting and why you're collecting this data itself. For instance, when you talked about things over here, ionic bond, you said lattice enthalpy, lattice energy, hydration energy, but you didn't seem to understand why they were doing that crap. That didn't make sense to you, right? That was not connecting at least. Or
Yeah.
I assumed that way maybe.
Kind of, yeah.
So that's where a disconnect starts happening. When you end up starting to, at the beginning itself, when you start disconnecting with the piece of information which is given to you, you slowly end up, not thinking about it too carefully. When you don't think about it too carefully, what happens is that becomes an unconnected piece of information in your brain. When it becomes an unconnected piece of information in your brain, anything which involves that connection will be something which can be only explained in your brain as an exception, because this piece of data is unconnected. So why are we learning each of these? Why bonds are formed? How does it form? All of this are the larger questions to basically discuss. They will be answered first by understanding what we are defining here, which is what is a bond, how are these bonds formed, and what to say, more critically, what is the kind of information we need to collect about these bonds. Because when you're studying something, we need to collect data about it. Only if we collect data can we start studying it. Because what does understanding mean? What do you think understanding is about? When we collect some data, we talked about how conceptual understanding comes. You talked about how, physically you have learned concepts, right? What does
Yes, sir.
conceptual understanding mean? What
Connecting
does
the
that mean?
dots, like connecting the dots between the
How does that happen
facts that you
usually?
have.
How does that happen usually?
Well, you have a initial fact, like a piece of data, and
Mhm.
then you learn more and more, and you have more pieces of data, and eventually you kind of start to see a correlation between them. Uh,
What do you mean by correlation here? That's what I'm asking actually.
like maybe a reason why something happens, like reason for the
Go more basic. What does correlation mean? Correlation is some connection.
yes,
Some
connection between
connection
both.
basically means ultimately everything goes like this. You collect data, then the conceptual part is effectively mathematical understanding. How mathematics connects it, connects the pieces. Data will be connected by mathematics usually, almost always. Now, sometimes we understand the mathematics directly. Sometimes we connect the mathematics in a different subject. Sometimes we just don't think about it from a mathematics point of view. We think of it as another logical understanding, or what to say, another data point. So in almost all cases, when you look at learning, you collect data. Usually data which you collect will be in the form of numbers, because the idea here is this: we are not born with the ability to understand everything, but we are lucky enough to be born with the ability to understand the language in which the universe is written, so to say. So what we do is we end up associating anything and everything with numbers. You told me atomic structure is completed for you, correct?
Yes, sir.
What is quantization?
Quantization means uh, it can only have a particular set of values.
What does it mean?
It means that it's
It means, effectively speaking, you can put a number on it. Effectively, that's what it means.
yeah.
So the idea there is, if I can basically represent something using mathematical data, direct, discrete mathematical data, technically that is something which is quantizable. And universe is basically something where practically everything is quantizable. So let's not go into that quantization thingy for now. But the idea is this: when you're going to be having anything taken into account over here, when we say data is collected, what type of data is going to be collected? Mathematical data. That mathematical data is going to be then interpreted. Now, how do we interpret that? That interpretation is going to be usually in other chapters. So this data which is collected here, this is your lattice energy. This is your hydration energy. Now, why do we collect these data here? Because these are data points which give us an idea about what is going to be the strength associated with an ionic bond.
Okay.
So the idea here is this: when you're going to be having, what to say, an ionic bond, consider an ionic bond, as you mentioned, is something. Explain what an ionic bond is in your own words.
It's a bond formed by the attractions between two oppositely charged species, ions.
Yes. How does that form?
It forms due to the attractions between, like the positive charge of the cation and negative charge of the anion.
Let's take an example and talk. So if I'm going to be having, say, sodium chloride,
Yes.
This is something where there is an Na plus and a Cl minus, correct? How is
Yes.
this formed? Is it formed by Na plus ions and Cl minus ions? What forms sodium chloride? This is formed by sodium and chlorine combining, now, dude.
Yes, sir. Yes.
Right. So when these two combine, it directly ends up forming that. So what's happening over here? This sodium is of course going to be losing one of the electrons, ends up
Yes.
getting ionized. Standard process ends up happening here. It ends up becoming an Na plus gaseous ion. This guy
Yes.
breaks.
Chlorine must dissociate.
So we are going to be
Break.
taking half a mole of chlorine here. So okay. So this guy ends up breaking over here to become chlorine atoms first, which then end up accepting an electron to of course end up becoming Cl minus
Cl
ions.
minus ion.
Finally, these two guys combine to give you your Na
Right.
plus Cl minus solid. Now, this is the general stepwise process which happens. Now, let's talk a little bit about what is happening in this case here when you're having the ionic bond here. The ionic bond is effectively the attraction between, average attraction between any pair of Na plus and Cl minus ions, correct? That's the way to ideally look at it. Now, the thing here is this. There is no individual pair of Na plus and Cl minus ions, right? That is where the lattice
Yes.
part comes into it. So, do you know what a lattice means?
Yes, sir.
So, what does a lattice mean? Tell me.
Sir, it's a uniform structure which has repeating units.
Mm-hmm. So, is that it? Anything else which you can tell me about a lattice?
Uh, it's a three-dimensional structure which repeats
Repeats,
on
correct. The most critical point is it is crystalline, which basically
crystalline.
means
Yes.
that its properties are well defined. All right. So when I say its properties are well defined, we can measure them multiple times and we'll keep getting the same measurement. That is an important thing to note, because ultimately remember, all of these things which you are learning now, these things were all done by scientists 200 250 years back. All of the understanding over here. So their understanding comes from the data they were able to collect. So quite a bit of what you will be learning will be having what to say, some historical shadows, so to say. In the sense, it might be obvious to you, but that scientists will be wasting unnecessary experiments to do it. For instance, in atomic structure, you'd have learned Dalton's model, then you'd have learned Thomson's, then you'd have learned Rutherford's, then you'd have learned Bohr, then you'd have learned everything is wrong, then you will be learning something where nothing is correct. So that's effectively how we close things in atomic structure. But what to
Yes,
say,
sir.
the idea there is, why do you learn it that way? Because that is the way history played out. That's the way we collected the information which we collected. Anyway, coming back to this over here, when it comes to any ionic solid over here, the way you put it across, we are going to be having in the crystalline structure there, the ions are going to be completely surrounded. So we can't really isolate any one individual pair of ions to actually find out what is the actual KQ1 Q2 by R squared. Because this KQ1 Q2 by R squared here is actually going to be the real measure of how strong the attractive force is going to be, correct? But the problem with this KQ1 Q2 by R squared over here will be this. You will end up having, okay, first of all, I think I jumped the gun here. Do you know what KQ1 Q2 by R squared means here?
Yes, sir. The Coulombic forces of attraction.
Yes, so this is a Coulombic force of attraction. This is the electrostatic force of attraction. Okay. So this is the electrostatic force of attraction. So when you're going to be considering this electrostatic force of attraction, we can say that the Q1 here is going to be, say, charge of cation. Q2 is going to be the charge of anion. And R is going to be distance
between them.
Between the cation and anion. Now, let's look at each of these three parameters here. So in this case here, we have just now talked about how the strength of the ionic bond, if I want to understand how strong an ionic bond is going to be, it is not that easy to calculate. right? Or rather, we don't have a direct way of finding out which ionic bond is stronger. What is the indirect way to find out which ionic bond is stronger here? You can find out how difficult it is to tear them apart.
Yes.
Correct? That is,
Yes.
I know that this system is bonded. If I tear it apart completely, I'm going to be spending some energy in the process. Correct? So how much energy am I going to be consuming in tearing apart this system? That is going to be a meaningful measure over here. Now, that is going to be, of course, your lattice enthalpy. Right? So lattice enthalpy is going to be something which is going to be a term which you'll be coming across a little bit later. The term you should be familiar with by now should be this. Correct?
Yes.
So now when I say lattice energy here, let's talk about the definition which you have learned in school for now. What is the definition you have learned about lattice energy? Can you give me the definition?
Lattice energy is the energy required to break apart uh, an ionic compound.
First of all, that is wrong. Okay, so lattice energy, let me give you the correct definition here. Lattice energy is going to be defined as the energy released during the formation of 1 mole of NaCl from 1 mole of Na plus ions in gaseous form and 1 mole of Cl minus ions in gaseous form, assuming they are being brought from infinite distance, where they do not have any attractions between them. It's an ideal type of case. So what is this lattice energy really measuring? It is measuring the energy released during the formation. Now, what definition you gave, that is for this guy. All right. The definition you gave, the energy required to break. That is going to be for the lattice enthalpy. So when we talk about the definition of lattice enthalpy is something which you can think of for the time being as modulus of lattice energy. Now, you will be learning more about this term called enthalpy in a much later chapter, not exactly much later, in a relatively later chapter called thermodynamics, and you'll learn what that means more clearly there. For the time being, though, it is just a word. It doesn't make much of a difference. What you need to understand here is lattice energy is energy released. Energy required to break that is generally called as lattice enthalpy. Okay, so in this particular case here, if I'm going to be considering this system here, when you're having an ionic bond. Okay, so we've got the ionic bond strength here being dependent on how much is the lattice enthalpy or lattice energy. Ultimately, both are the same because they are both, inverses of each other. So if I have lattice energy being, say, some amount of energy released, one point I need to make clear here. Let me just introduce that point here. When it comes to chemistry, sign convention is going to be very important to pay attention to with respect to energy. So when I say sign convention here, what do I mean? The lattice energy, which is energy released, we will generally be giving it a sign of negative. So for instance, when they give you lattice energy value in a question, it will be given with a negative sign. If they have not given you with a negative sign, that means they have made an error. But here is where the unfortunate reality comes in. Your job is not to find errors in their papers. That is not the job at the game here. Your job is to basically score marks as efficiently as possible. That's the name of the game you have to play here. So only look at it from your benefit. Do not put your ego on the way. Ego is not worth it in this. Anyway, coming back to the point here, lattice enthalpy is going to be, if the lattice energy for something is going to be, say, minus 300, that means 300 kilojoules per mole, if I'm assuming it's kilojoules per mole, was energy released during formation of some ionic compound. If that same ionic compound is torn apart, I have to supply that 300 kilojoules over there. That lattice enthalpy will be having a positive sign. So when I give any system a positive sign, chemistry may, it means I'm supplying energy to that system. If I'm giving it a negative sign, that means I'm removing energy. Anyway, that is a later thing to discuss in more detail. For now, if I'm going to be considering this lattice energy, what are the factors do you think which should be mattering over here? It is ion attraction, electrostatic attraction, correct? So
Yes,
if it is electrostatic attraction, it should logically depend only on this kq1 q2 by r squared.
yes.
So let's try to analyze this factor a little bit more clearly. So which one is going to be playing a bigger role? Cation charge, anion charge, or cation size or anion size? There are 4 parameters here now to look at.
Yes, sir.
4 variables are there which can be played around with. One is going to be R plus charge, which is my cation's charge. Another is R minus charge. Another is going to be R plus size. And the last one is, of course, going to be R minus size.
Yes. Yeah.
So let's try to understand each of these 4 factors now a little bit. Which factor is going to be playing a more critical role here, do you think?
The size.
Why?
So because it's whole squared.
Very correct. Effectively speaking, the size is going to be having a square relationship. So obviously, bluntly, the mathematics tells us that that should play a far more critical role. Okay.
Yes.
Now, let me add a twist to the situation here. If I'm going to be having a cation or an anion taken in this lattice arrangement, a 3-dimensional repeating arrangement, crystalline arrangement, what's going to be happening? Will I have one ion having only one ion next to it? A cation will have only one anion surrounding it, or will it have multiple? What do you think should happen? Multiples. Same thing should apply for the anion as well, correct? So there is actually one more factor here, which is a hidden factor. Let me not call it Z. Let me take it as some random variable X. What is that X going to be? That X is going to be some kind of a multiplying factor, which depends on the lattice actually.
Okay, got it.
So let's take it as a lattice dependent factor. Right, it's going to be some lattice dependent factor. You will of course learn what kind of a factor it is going to be a little later in a different chapter. For now, it's a lattice dependent factor. Okay, so there's a lattice dependent factor over here, and you're going to be having R as the other main parameter. Now the Q1 and Q2, they don't really matter so much, right? Ultimately speaking, the Q1 and Q2 will matter though when they can influence the size. Think, when will they start influencing the size? If I have a higher R plus charge, what happens in that case?
The size decreases.
More dramatically. We just talked about that with the lithium plus, aluminum 3 plus, and magnesium 2 plus thingy. So it decreases more dramatically, not necessarily exponentially. Don't think of it as exponentially. Because what was the image I told you to look at over there? It's like you've been robbed once.
Yes.
So when you've been robbed once, you'll protect your valuables a lot more seriously. But does that mean you can completely protect your valuables and reduce your size tremendously? No, not really.
No.
You will protect it much more than a linear factor, but it will definitely not be completely exponential. So that's what's going to be happening here anyway. So in this case here, you got it correctly. The size is the main factor here. So when you're going to be comparing ionic bond strengths, or if they're going to be talking about which system is going to be having greater ionic bond strength, or if they're asking you to compare this compound and that compound with lattice energy, let's take an example and see. If I'm going to be comparing, say, lithium chloride and magnesium chloride, which will have more ionic bond strength? Lithium chloride and magnesium chloride. So let me directly put those two guys down. Magnesium. Why magnesium?
Because it's smaller in size.
It's smaller in size. It is smaller in size, and you're going to be having magnesium 2 plus having double the charge as well. So both factors play a role over here in increasing the situation here. So
Yes.
you're going to be having MgCl2 basically winning over here. How about if I compare, say, MgCl2 and MgO? What happens then?
Uh,
Things get complicated here, correct?
yeah, kind of.
Why are they complicated? See,
So because yeah.
don't try to get to an answer just for the sake of getting to an answer. There's nothing wrong with getting stuck in a place and understanding why you are stuck. Because when you understand why you are stuck, it means you have understood the parameters at play here. In this case here, magnesium are same. Oxygen has a higher
Yes.
charge, but its size may be a problem because it's got 2 minus charge. Chlorine
Yes.
though is a -1, but it is naturally itself much larger, right? Because
Yes.
it's the next period. It's not in the same period as oxygen. So even if oxygen is -2, Cl -1 should logically be larger than that. So we've got in this particular case here, R wise, if I'm comparing, oxygen and magnesium should have smaller R. Why? Because magnesium is the same in both cases. Oxide is going to be definitely smaller than chloride. That's the conclusion we got
Yes.
to, right?
Yeah. Yeah.
So you got the R value done. Charge wise, magnesium is one thing. Oxygen is going to be having double the charge of a chlorine. The only thing which might be a factor is that lattice factor X. And assuming all factors are going to be the same, at this stage here, lattice factor should not be a thing which you should really worry about. So what should be the logical answer at this stage here? Which will have
MgO.
higher lattice energy? MgO. As simple as that. So if they're asking you which is going to be having a stronger ionic bond, answer will be MgO. But the question will be a little bit more different if they're asking you which has higher percentage ionic character. This is where your Fajan's rule comes into play.
Fajan.
Now, when we talk
Yes.
about what is a percentage of ionic character, why is it that we are studying this percentage of ionic character? What is the purpose of studying Fajan's rules? Why do we study Fajan's rules? You tell me that for a second. Why do you think we study Fajan's rules? What's the purpose behind studying it?
As I said, to find the covalent nature in an ionic compound.
What do you mean by covalent nature now? We've talked about ionic nature now, and we've talked about the data points collected, right? The data points
Yes.
collected with respect to ionic nature are lattice energy. We have not delved into hydration energy yet, but hydration is also dependent on Kq and Q2 by R squared.
Yes.
So in that case there, the hydration energy is going to be dependent on one extra factor there. The Q2 will come from water. All right. And there will be another parameter here, say like X over here, which is going to be number of water molecules surrounding.
Okay.
R is of course going to be distance. So this is going to be your hydration. So hydration also depends predominantly on Q1 and R. So if I'm going to be having cations, they will have phenomenally higher hydration energy normally, especially if the cations are having a higher charge. Anyway, that is one aspect of things. Okay, now let's come to why we learn ionic character again now. So when it comes to any ionic bond, I have a question here. Can an ionic bond be perfectly 100% ionic? If so, how? If not, why? Can an ionic bond be perfectly 100% ionic? What does ionic bond mean? One species is given away, another species is taken, correct?
Yes. Well, it cannot be 100% ionic because there will always be some sort of force which is wanting the electron from the other species. So it cannot be completely 100%.
Let's
There'll be at least
look at it. No, there are possibilities of it to be 100% ionic. Let's not neglect the possibilities. Say, Fajan's rules, the fact that they've defined it, tells you indirectly, being a smart kid, You're basically connecting the dots, assuming that you are connecting the correct dots over here. You're trying to connect the dots with the fact that, the logical answer which I'm looking for over here is that no ionic bond is 100% ionic. Right, that's what you're trying to do over here. Is that correct?
Yeah.
So there's nothing wrong with it. I'm just saying that, sometimes it is also beneficial to look at what they're trying to say. So let's look at what is a 100% ionic scenario. So if I'm going to be, say, Bill Gates, fucking filthy rich at another level, if I throw away a few $1,000 to somebody, it doesn't matter. That's a perfectly ionic interaction between me and that person, right? So there's no problem at all, but there's not much attraction. Let's not go to the percentage, or let's not go into the how ionic and how strong the attraction is. Attraction is not there, but an ionic scenario is created, right? So when you talk about any ionic scenario, the ionic scenario can be created only when the system which is giving is more than happy to give, and after it has given, it is not going to feel any regrets. It is not going to feel even the tiniest bit of a tinge that, oh, that fellow's taken my shit. So that is the idea here. When it comes to any general ionic bond, what happens is you never get that perfection. You are correct with your answer. But why do you never get that perfection? Because if you want to have a perfect system, you need to have a very large sum of, very large number of electrons be present that it will be happy to throw away one electron. There are no elements in the entire system we know which are happy to throw away any electron. There is no system. So that is never going to be happening. So after something has thrown away an electron, however willingly it throws it away, however stable it becomes, that system which is formed after it has lost the electron is now something which is more greedy for electrons.
Deprived. Yeah.
So what happens is you end up having the electronegativity of the cation increasing after it becomes a cation. When it was an atom, it was not that electronegative. It was willing to form an ionic bond. But after it has become the ion, now it is going to be having an issue with the fact that, I've already given away. I'm not happy completely right now. I'm happy in terms of stability, but I would like this stability with my old electron. Or a little bit of my old electron at least. So that is effectively what happens. So you can think of it as, when you end up having any cation, this character is called polarizability. So when we talk about polarizability, polarizability is the extent to which the electronegativity of a cation ends up increasing. So if I take this as the cation, original atom was larger in size, so it has become smaller. So if this guy is in an interaction with an anion, anion is usually larger in size. That's why I've depicted it like this. So originally it was supposed to be a perfect ionic interaction here, no residual covalent character. But what ends up happening is, this fellow, which is the cation, has now got enhanced electronegativity, while the anion obviously has become larger in size, fatter. So if it has become larger in size, think of a classroom where a teacher is in the front and there is a class of say 20 students. If let's say the class suddenly becomes 40 students and the size of the classroom has doubled, proportion, not doubled necessarily, has increased proportionally to the number of students. What happens to the control which the teacher can exert on the student? Will that increase or decrease?
Can you repeat?
If I'm going to be having a class with a teacher,
yes,
let's say some X students in the beginning, then the class increases in size. The number of students also less control. So effectively, that's the same thing which happens over here. The nucleus of the anion now is able to exercise less control over the electron density which it is already having. So when that happens, what happens in this case over here? You will end up having this anion here being less electronegative than expected compared to the original atom, and the cation is more electronegative than expected compared to its original atom. So this will basically siphon off a little bit of electron density from the anion. When it siphons off a little bit of electron density, what was supposed to be a full-blown +1 and a full-blown -1 will start changing. This will be something less than +1. slightly less than, not that much less than, slightly less than plus 1. This will be, obviously, this will be consequently slightly more than a minus 1.
Greater.
That's basically how it's going to be. So you're going to be having the plus 1 being slightly less than a plus 1, whereas the minus 1 becomes slightly less than a minus 1. So this is effectively what's happening when you're going to be having covalent character coming in. Now, I think your timing was 8:30 to 10 o'clock today. That's what Imatej had mentioned to me. So what kind of timings work for you normally?
Well,
What time do you generally end up being comfortable with?
8:30 to 10 is comfortable with me, sir. Yeah.
And what time do you have dinner?
What dinner I usually eat like at 8 o'clock.
8 o'clock, early enough. Nice, clean. And your sleep time?
Sleep 10:30, 10, 15, 10:30.
Okay, so you'll be crashing soon then. Okay, all right. Fair enough. So, all right. What are the general areas of weakness which you have in chemistry? I want you to think about that. If we are going to be having another session, I like this session. Obviously, whether we have another session is dependent on you. If we are having another session, I would like to, start off with a particular chapter directly. So, what exactly is your situation? You decide. Do we start off with an older topic and wipe that clean first, then come to this and start off wiping this clean? Or my personal recommendation would be we'll start off with whatever topics are happening currently, and we'll first continue on and fix that first, because that will be helpful for you in your school exams right now.
Yes.
And after that, we can do any patch-up work required for any older topics if you have any issues with respect to them. That's effectively how I would look at working forward over here. Any thoughts?
Yes, sir. I agree. I think that would be more beneficial.
Okay, cool. All right. It was a nice interaction, Aman. Nice talking to you.
Same. Yeah.
So make sure that you are, clear with any issues you have in the previous topics. We can do something like this. I will start off with chemical bonding and directly start discussing the chapter, moving forward at a brisk pace, so to say. Wherever you are finding it complicated to follow things, be free.
Yes,
Feel free to open your mouth and ask your doubts.
yes,
This
sir, yeah.
cannot work otherwise. And I think from the next session onwards, we can shut the camera also to an extent, because it is consuming an unnecessary amount of data, I suppose. So
Yes,
we can make it much more streamlined thingy. I probably will be changing to a different platform to basically end up taking classes on road, mainly because this is my startups account. I would much rather not use this. So I would much rather not use this. And my old my Zoom account is also unfortunately tagged with my older employer Narayana. I would prefer not to use that as well. So I have a random ID which I've created for YouTube purposes. So would it be okay if we end up interacting on that directly? Because Google Meet is one way. I would like to keep a record also of the discussion, so that if you want to go back and check it out, that will be more convenient. So I'm planning on basically directly streaming the class and dumping it on YouTube itself, and you can check it out whenever you want. Us type ka. Would that work for you?
Yes, sir. Yeah, that sounds nice. Yeah.
Cool. Okay. All right. And
Yes,
what is the situation about assignments is something which I would like some information from you also. How is your system of practicing questions? I would like a more cleaner idea about that by next session. So think about what you want to tell me regarding that, and I'll see you in the next session. Nice to meet you, dude.
Yes, sir. Nice to meet you,
Bye
sir.
bye.
It was very nice,
Yeah.
the class.
Good night.
Yeah. Good night,
Yeah.
sir. Have a night.
Good night. Bye bye.
Bye.